class, Mrs. Matheson here. We're covering Unit 6, Notes 3 on exponential decay today. Our learning target is I can graph, model, and apply exponential decay functions. So decays are going to be very similar to growth, but instead of adding, we are subtracting out our rate of change. Remember, we want a rate of change not as a percentage. Okay, so let's take a look at our first one. Our rate of change is already in a decimal form. It's not a percentage. So let's do our equation. 16 times 1 minus 0.45 to the t. 1 minus 0.45 is going to give us 0.55 to the t. Okay, again, let's think of this as t not x. And we're going to go from -2, -1, 0, 1, and 2. We're going to type this into our calculators. So y equals 16 times 1, we're going to put in 0.55 to the -2 power. Remember to use that little caret button that looks like this to do your exponents. All right, we get 52.89. Let's round that to 52.9. All right, plugging in -1. Go ahead and type this into your calculator. We get 29.09, so 29.1. Plug in 0. 0.55 to the 0 power. We end with 16. Y equals 16 times 0.55 to the first power. We get 8.8. And our last one to the second power, 4.84. So we're going to round that to 4.8. All right, so we talked about in class that sometimes our values are so large, like these two, that we won't be able to graph them. So we're going to start with our 0, 16, and then we have 1, 8.8, and then 2 at 4.8, so almost up to 5. So here you have to use a little bit more creativity with drawing your curve. Now notice our decay is going down with that gentle curve. All right, let's look at number 2. Here, our rate is given to us a fraction, so that's just fine as long as it's not a decimal, not a percentage. So we have 15 parentheses 1 minus 1/3 to the t. 1 minus 1/3 leaves us with 2/3. Please leave it in the fraction form because you're going to get a vastly different answer, almost off by almost like an entire 3 to 4, and it just gets bigger if you don't use this fraction. So again, t, -2, -1, -1, there we go, 0, 1, and 2. So let's go ahead and we're going to just use our calculator. We talked about putting fractions into a calculator. So we have 2/3 to the -2 power. All right, so that's going to leave us with 33.75. So let's just round that to 33.8. 33.8. Okay, go ahead and pause the video, fill in the rest of the chart, and come back and see if we're at the same place. All right, take a peek. How does yours match up? Good. Okay, so graphing it, again, we're not going to be able to always graph our points. This one we can't. This one we kind of can. Our graph goes up to 19, so we can go 20, 21, 22. Okay, and then, oops, that's at -1. Sorry about that. So we're at 22 at -1. 0, we're at 15. 1, we're at 10. And 2, we're at 6.7. Again, because it's decay, we're seeing it have that gentle curve down. Okay, so let's put this into some word problems, which is a really good application. A fully inflated raft loses 6.6% of its air every day. The raft originally contains 4,500 cubic inches of air. Write, that should say an equation, to represent the loss of air using the general equation for decay. So our general equation for decay, remember, was y minus our rate. Okay, so our original value we start with is 4,500. 1 minus, here we are given a percentage, so we need to change this from a percentage by moving our decimal point to the left. So we have 0.066 to the t. If we subtract 1 minus 0.066, we get y equals 4,500 times 0.934 to the t power. So this is the equation. They ask us for an equation. B says to estimate how much air will be lost after 7 days. Okay, so 7 days is our time. So we're going to go ahead and plug that in for t. Okay, typing this into our calculator. Watch your parentheses. Use your caret. All right, so we end up with 2,790.23 cubic inches. So we can say inches cubed. All right, so I want you guys to do problem 4. You're going to set up the equation, and then you're going to write the equation and find the population for 2013. We will pick up with problem 5 through the end tomorrow. See you guys then.